Hey, Algebra. What I decided to do for today was just go over a few more problems to give you kind of a refresher and reminder, and in case you were struggling with some things, just to give you a little bit more repetition to see what's going on. I'll try to keep this to about 10 minutes. I won't go over everything. And if you think that you're comfortable, then by all means, go ahead and just continue on with the study island assignment. I also want to mention that with the study island assignment, I put it in the Google Classroom. There's going to be 1 day's worth of Alex time and topic goals, so 45 minutes and 5 topics. So between yesterday, today, and tomorrow, hopefully we'll be able to get all of this finished. All right. So this particular one, yesterday when we looked at this, I talked about using SADMAP and how we were able to just divide everything by 7 to begin with. I want to show you how this works using the distributive property instead, which is a viable way to do it as well. So if I distribute, I would take 7 times x and 7 times 4 and get 7x plus 28. So it works this way as well. Obviously, the math is correct both ways, so the answer will end up being correct. And then we're looking at isolating the x. So now we would get rid of the 28. Since it's plus 28, we are going to subtract 28 from both sides. So in the middle, that leaves us with 7x. Over here, we've got 105. Over here, we've got 35. And then dividing by 7, we end up with 5 is less than x is less than 15. All right, so we got answer B. So moving on to this word problem here. Brandon writes math problems for a publishing company this week. He has already written 10 problems. There are 3 days left in the work week, so he set a goal for himself to write 31 problems this week. So that's what the inequality is talking about. So the first one, he already has 10 problems, and then he's got 3 days. And what he wants to figure out is how many problems does he have to write each day in order to reach his goal of 31 here. All right, so solving this, we're going to subtract that 10 first. Which will give us 3x is greater than or equal to 21, because 31 minus 10 is 21. And then hopefully you can see when we divide by 3, x is going to end up being greater than or equal to 7. And now we have to just interpret the words and realize what this greater than or equal to sign means. All right, obviously we want anything that's more than 7. If he hits 7, which is what the equal sign is, he will get exactly 31. All right, if he can average 8 problems a day, he'll exceed his goal. It can be higher than that. So we want the one that says he needs to write at least 7 problems each time, which ends up being B. All right, if we did at most 7, that means 6 could be an answer, 5 could be an answer, and he would fall short of his goal. So we got B. Okay, a graphing one. So this time they give us 2 different inequalities to solve here. So let me go ahead and take a look at this first one. I'm going to subtract 5. So we end up with negative 2x is greater than 4. And I'm glad they gave us one like this, because this is one where we have to divide by a negative. So we have to make sure anytime you multiply or divide both sides of an inequality by a negative, we got to flip that inequality sign. So it turns into a less than or equal to. All right. The other inequality, subtract 4 from both sides. So I end up with 3x is greater than 6. I divide by 3, and I end up with x is greater than 2. All right, 20 seconds left. See if I can get this in. So x is less than negative 2, meaning I'm going to put an open circle at negative 2, and anything less is in that direction. X is greater than 2, once again, an open circle, and I'm going to have anything in that direction. Because it's an or, we can have both of these. So before moving on to the next one, I just wanted to point something out. And I know I did this yesterday too. I couldn't put an open point where I wanted. And then I read the instructions. Surprise, surprise. It says click on an existing drawing to add an open point, which means I need to put a closed point before I can change it to an open point. I accidentally discovered that yesterday, but now looking at the instructions, it makes more sense. And then we had the shade in these directions here. Okay, another absolute value. I'm glad an absolute value problem came up because I know there's a lot going on with this. This might take up the whole 5 minutes of this thing just in itself. So when we're doing absolute value, first thing that we want to make sure of is we need to isolate the absolute value portion. All right, so we kind of treat that as a variable itself. So in order to do that, SADMEP, I got to subtract this 2 from both sides. So I have -2, and then the absolute value of 6 minus x. Well, we're going to have all kinds of negatives in this one. Is less than or equal to -12. And then, since it's -2 times that whole absolute value, I need to divide by -2, keeping in mind that when I divide by -2 here, I need to flip that sign. So I have the absolute value. Let me make that a little bit longer. Absolute value of 6 minus x is now greater than or equal to +6. And this is what we talked about before. Because it's greater than or equal to +6, we have 2 different numbers that are 6 units away or more. Okay? So we have to consider 2 different inequalities here. One where 6 minus x is indeed greater than 6. But remember, absolute value is a number's distance from 0. 6 is not the only number 6 units away from 0. So is -6. So we have to consider 6 minus x compared to -6. But when we add that negative, we have to flip that inequality. So instead of greater than or equal to, we're talking about less than or equal to. And I want to talk about the reason why that is just for a second. So if we look at a number line and we look at 0 and we look at 6, all right, we need to consider all of the numbers that are at 6 and higher than it. But when we flip it around to -6, all right, we kind of look at, okay, in here we're going to have 7, we're going to have 8, we're going to have 9. They're all more than 6 units away from 0. But we also have to consider -7 and -8 and all of those which are more than 6 units away from 0. And those numbers are less than -6. So the higher we go with the negatives, the farther away from 0 it is, the smaller the number actually is. So that's why we have to switch that sign. I don't think I explained that yesterday, and I thought that was an important thing to get out today. All right, so solving both of these, we're going to subtract 6 from both sides in both inequalities. And that's going to leave us with -x is greater than or equal to 0 in this case, and -x is less than or equal to -12 in this situation. Now this is key here, because technically we are about to divide by a negative. We can look at this as -x and taking the opposite of both sides, or I know some people like to think of this as -1x. So if we divide both sides by -1, that's going to flip the inequality. All right. Regardless of it being 0, we still have to make sure that we flip that inequality. So dividing by -1 on this side over here makes it x is greater than or equal to 12. See, I knew we were going to take up most of the time here. So now our answer is x is less than 0 or greater than 12. We're looking at A. So if I don't get cut off, finish this assignment and you're Alex here. And I should be back tomorrow.